It's already happening. Not to us specifically, but to worlds like ours. Out there in a galaxy older than our sun by billions of years, planets have risen, evolved, and had far more time than Earth ever has. And yet we see nothing. No ancient megastructures, no interstellar empires, no evidence that anyone made it far. That shouldn't be normal. Because if intelligent life is common, the Milky Way should look crowded. Instead, it looks erased. And the question isn't why the galaxy is empty. It's what keeps clearing it. Welcome to Simulation Hypothesis. This is where we slow down and question the comfortable stories we've told ourselves about space, life, and our future. We don't chase cinematic aliens or dramatic invasions. We look at the numbers, the timelines, the physics, and sometimes when you follow those carefully enough, the universe stops feeling mysterious and starts feeling deliberate. Because if you step back for a second, something about our galaxy doesn't make sense. The Milky Way is not young. It's over 13 billion years old. Our sun is about 4.6 billion years old. That means there were potentially billions of years for life to begin somewhere else before Earth even formed. Billions. And life on Earth appeared almost immediately once conditions allowed it. Within a few 100 million years of the planet cooling down, there were already microorganisms, which means if chemistry is even slightly generous, biology might not be rare at all. But intelligent life, technological life, is what matters here. And that's where the silence becomes unsettling. Because if intelligence arises even once every few million years in a galaxy with hundreds of billions of stars, there should be civilizations out there that are not thousands of years ahead of us, but millions or billions. And civilizations with that kind of head start wouldn't be subtle. They would reshape stars. They would alter entire systems. They would leave scars in the fabric of the galaxy that we could detect with telescopes. But we don't see that. We see stars. We see dust. We see ancient light traveling quietly through space. But we do not see empires. That contradiction has a name, the Fermi paradox. Enrico Fermi famously asked a simple question: where is everybody? It wasn't a philosophical question, it was statistical. If life is common, the galaxy should not look this empty. Now here's where it gets uncomfortable. There are only a few logical ways to resolve that paradox. Either intelligent life is incredibly rare, so rare that we might be alone, or intelligent life appears and then disappears. And that's where the thumbnail image stops being symbolic and starts feeling predictive. Because Earth fading into dust isn't fantasy. On cosmic timescales, it's routine. Stars explode. Gamma ray bursts sterilize regions of galaxies. Asteroids strike planets. Supervolcanoes erupt. Climate systems collapse. Magnetic fields weaken. Civilizations rise. Civilizations fall. And the universe does not pause for any of it. But natural disasters alone don't fully explain the silence, because the galaxy has had time to recover from those. Life can restart. It has here. Which leads to something darker, something physicists and cosmologists call the Great Filter. The Great Filter is not a specific event. It's a bottleneck, a stage in the progression from simple chemistry to interstellar civilization that is almost impossible to pass. Maybe it's the leap from single-celled life to complex organisms. Maybe it's the development of intelligence. Maybe it's surviving technological adolescence. And that last one is where things start feeling personal. Because technological adolescence is exactly where we are. We split the atom less than a century ago. We industrialized the planet in 200 years. We altered the atmosphere measurably in a geological blink. We built machines capable of self-replication, artificial decision-making, and global reach. In cosmic terms, we went from cave paintings to nuclear weapons in about 3 seconds. That kind of acceleration is not stable. Brian Cox often points out that the laws of physics don't care about optimism. They don't reward ambition. They enforce limits, relentlessly. Energy constraints, thermodynamic costs, radiation exposure, finite planetary resources. Even if a civilization avoids war, avoids ecological collapse, avoids internal instability, it still faces physics. And physics is brutal. Interstellar travel isn't just difficult, it's almost prohibitive. Even at 10% of the speed of light, which would be an engineering miracle, crossing the galaxy would take 1,000,000 years. That means expansion is slow. Communication is slow. Coordination across stars is nearly impossible, which suggests something terrifying. Civilizations might not spread quickly enough to outrun their own fragility. They ignite, they peak, they destabilize, and before they ever become visible across the galaxy, they fade. Over and over again. Now pause there for a second, because if that pattern is real, then what we're seeing when we look up at the night sky is an emptiness. It's aftermath, a graveyard so ancient that even the graves have eroded. And Earth is not special in that equation. Our planet has been stable for an unusually long time. A strong magnetic field protects us from solar radiation. A large moon stabilizes our tilt. Plate tectonics regulate carbon cycles. Jupiter acts as a gravitational shield against some cometary impacts. We hit a cosmic lottery. But lotteries don't last forever. The sun will brighten gradually over the next billion years, eventually boiling away Earth's oceans. Asteroid impacts are statistically inevitable over long enough timescales. Nearby supernovae are rare, but not impossible. And then there are threats we haven't even discovered yet. That's why the fading Earth image matters. Because it doesn't require malice. It doesn't require invasion. It doesn't require monsters. It just requires time. And time is undefeated. But here's the twist, because this isn't just about astrophysical disasters. The Great Filter doesn't have to be external. It could be internal. It could be that advanced civilizations reach a level of technological capability where the risk of self-destruction rises faster than the probability of long-term survival. Nuclear war. Runaway artificial intelligence, biotechnological catastrophes, uncontrolled climate tipping points. And before you dismiss those as science fiction, remember that every single one of those is rooted in real science. We already possess the tools for global catastrophe. We just haven't used them fully. Which brings us back to the silence. If even a small percentage of civilizations fail at this stage, if most don't survive their first few centuries of advanced technology, then the galaxy would look exactly as it does now. Empty, not because life never forms, but because it rarely lasts. And that possibility changes everything. Because if the Great Filter is behind us, if the hardest step was the origin of life or the leap to intelligence, then we're extraordinarily lucky. But if the Great Filter is ahead of us, then the silence isn't mysterious. It's a warning. And that's where the conversation stops being academic. Because when you look at Earth today, politically unstable, ecologically strained, technologically accelerating, it doesn't look like a species that has mastered long-term stability. It looks transitional. It looks volatile. It looks young. And youth in cosmic terms is dangerous. But here's the deeper layer. Even if we survive, even if we avoid self-destruction, even if we manage climate, manage resources, manage technology, the galaxy still presents a long-term problem. Entropy, stars burn out, galactic collisions occur, radiation environments change. The Milky Way will merge with Andromeda in about 4 billion years. Black holes grow, energy becomes less accessible. The universe trends toward disorder, which means the ultimate Great Filter may not be a single event. It may be inevitability itself. Civilizations might not be wiped out violently. They might simply exhaust the window of opportunity that physics allows. And if that's true, then the emptiness of the galaxy isn't accidental. It's structural. Life may be common. Longevity may not be. And Earth, brilliant, fragile Earth, may not be an exception. It may just be mid-cycle. which raises the most uncomfortable question of all. Are we early in the history of intelligent life in this galaxy? Or are we late? Because if we're late, and the galaxy has already tried this experiment countless times, then whatever erased them may already be in motion here. And we might not recognize it until it's too late, but that's not all. If the galaxy is quiet because civilizations keep failing, then the next question isn't philosophical. It's statistical. How often does a planet like Earth get erased? Not metaphorically, not poetically, physically. Because before we assume self-destruction is the dominant cause, we have to look at the cosmic hazards built directly into the structure of the Milky Way. Start with impacts. We tend to think of asteroid extinction events as rare, cinematic disasters, the kind that wiped out the dinosaurs 66 million years ago. But rare only makes sense relative to human lifetimes. On geological timescales, impacts are routine. Earth has been struck by objects large enough to sterilize continents. Some early impacts during the late heavy bombardment may have vaporized oceans repeatedly. If life survived that period, it did so through resilience, not comfort. Now imagine that pattern extended across billions of star systems. Every planetary system forms with leftover debris, asteroids, comets, unstable gravitational resonances. Over time, those objects scatter. Some collide with planets, some trigger global fires, some cause atmospheric collapse. We were lucky. Jupiter absorbs or deflects a significant number of potential impactors. Our moon may also stabilize orbital chaos, but that configuration is not guaranteed elsewhere. A civilization might evolve on a planet without a massive outer gas giant acting as a gravitational shield. Its extinction probability rises immediately. And impacts are only the beginning. Consider gamma ray bursts. These are among the most energetic events in the universe, massive stellar explosions that release tightly focused beams of radiation. If one occurred within a few thousand light years and its beam intersected Earth, it could strip away the ozone layer almost instantly. That doesn't vaporize the planet. It does something subtler and possibly worse. It floods the surface with ultraviolet radiation, collapses food chains, and triggers mass extinction. And gamma ray bursts are not theoretical, we observe them. They are rare in any single region of the galaxy at any given time, but the Milky Way is vast and ancient. Over billions of years, the odds accumulate. Then there are supernovae. A nearby supernova within about 30 light years could dramatically increase cosmic radiation levels on a planet's surface. That radiation doesn't just cause sunburn. It damages DNA, it mutates cells, it alters ecosystems. Again, not guaranteed extinction, but increased instability. Over enough time, even small increases in extinction probability add up. This is the math that becomes uncomfortable. If a planet has a 99.9% chance of surviving any given million-year period, that sounds safe. But over a billion years, that compounding probability collapses. Stability isn't about surviving one disaster, it's about surviving all of them. And that's only external threats. Internal planetary dynamics can be just as destructive. Supervolcanoes are not rare in Earth's history. The Toba eruption around 74,000 years ago may have nearly wiped out early human populations. Some models suggest our species passed through a severe genetic bottleneck during that time. Now scale that up. On another world, a slightly more volatile mantle, a slightly thinner crust, a slightly different tectonic pattern, and global eruptions could become civilization-ending events. Magnetic field fluctuations add another layer. Earth's magnetic field protects us from solar wind and cosmic radiation, but magnetic fields reverse, weaken, fluctuate. During weakened periods, radiation exposure increases. On Mars, the loss of a global magnetic field contributed to atmospheric stripping. And that's the key word, stripping. Atmospheres are not guaranteed permanent features. Solar wind, especially around active stars, can erode them over time. Which brings us to stellar behavior. Our Sun is relatively stable. It's a G-type main sequence star with moderate variability. But many stars in the Milky Way are red dwarfs, smaller, cooler, but often far more volatile. Red dwarfs flare violently. Their habitable zones sit extremely close to the star, meaning planets there are tidally locked, one side always facing the star, the other in perpetual darkness. That creates extreme atmospheric circulation challenges. Worse, stellar flares from red dwarfs can strip atmospheres entirely. If most potentially habitable planets orbit red dwarfs, and statistically, many do, then long-term biological stability might be far rarer than initial habitability estimates suggest. So even before we consider intelligent life, the universe imposes filters. Chemical formation, planetary stabilization, atmospheric retention, magnetic shielding, impact survival, radiation shielding, stellar stability. Each stage reduces probability. But here's where the math becomes chilling. Even if all those stages are passed, even if life evolves and intelligence emerges, the timescale matters. Because the window for advanced civilization might be narrower than we assume. Earth has been habitable for roughly 4 billion years. Complex multicellular life emerged only about 600 million years ago. Technological civilization, barely 300 years. That means 99.99999% of Earth's habitable history had no radios, no satellites, no industrial signatures. So if we're scanning the galaxy looking for detectable civilizations, we're searching for a phase that may last only a few thousand years per planet. Out of billions, imagine 1 million planets that each produce technological civilization for 5,000 years before collapse or transition. 5,000 years is nothing. If those civilizations are not synchronized, the odds of overlap shrink dramatically. Two civilizations might exist in the same galaxy, but miss each other by millions of years. Silence doesn't require extinction. It only requires misalignment. But extinction probabilities still loom. Because once a civilization reaches technological capability, new risks emerge. Energy use scales rapidly. Industrialization alters climate. Artificial intelligence changes decision dynamics. Biotechnology increases pathogen potential. Weapons become planet scale. And here's the part people underestimate. Technological risk scales faster than biological adaptation. Evolution works slowly. Technology accelerates exponentially, which means the gap between what a civilization can build and what it can safely manage may widen dangerously. The nuclear age is less than a century old. Yet in that time, humanity built arsenals capable of self-annihilation. Climate change unfolded within 2 centuries of fossil fuel use. Synthetic biology is advancing at breathtaking speed. Artificial intelligence systems now influence infrastructure, communication, finance. None of these are inherently fatal, but each increases systemic complexity. And complex systems fail, not because they are evil, but because feedback loops, unintended interactions, and cascading failures are difficult to predict. In statistical risk modeling, low-probability catastrophic events dominate long-term outcomes. If there is even a small annual probability of civilization-ending catastrophe, the cumulative risk over centuries becomes significant. This is sometimes called the doomsday argument framework in probabilistic terms, not prophecy, but accumulation. And now connect that back to the silence. If most civilizations last only a few centuries after reaching advanced technology, the galaxy will appear empty most of the time. Not because life is rare, because stability is rare. And this interpretation aligns disturbingly well with what we observe. No Dyson spheres, no obvious megastructures blocking starlight, no widespread engineered anomalies in galactic surveys. Which means one of 2 things. Either advanced civilizations almost never arise, or they almost never last long enough to reshape their surroundings. Now bring it back to Earth. We've existed as Homo sapiens for roughly 300,000 years. We've been industrial for about 200. We've been nuclear for under 100. From a cosmic perspective, we just lit a match in a dry forest, and we don't yet know whether the forest is damp or explosive. But that's not all. Because even if a civilization avoids self-destruction, avoids asteroid impacts, avoids gamma-ray sterilization, avoids runaway climate collapse, there's still cosmic entropy. Stars brighten over time. Our sun will increase luminosity by about 10% over the next billion years. That may sound trivial, but it will eventually push Earth out of the habitable zone, triggering ocean evaporation and greenhouse runaway. That's not avoidable by policy. It's stellar evolution. Long before the sun becomes a red giant, Earth will become inhospitable, which means any civilization that doesn't expand beyond its home planet eventually faces a hard limit. And expansion isn't simple. Interstellar travel is constrained by relativity. Even 10% light speed requires staggering energy. Generation ships introduce sociological fragility. Communication across stars suffers decades-long delay. Expansion is slow. Disaster can be sudden, which leads to an unsettling asymmetry. It may be easier for a civilization to collapse than to spread. That imbalance alone could explain the emptiness. And that emptiness, again, is not neutral. It's data. The Milky Way has had billions of years to produce visible, large-scale civilizations. Yet surveys find none. Not faint signals. Not engineering signatures. Nothing obvious. Which suggests either we are among the very first, or we are one of many attempts. And the attempts do not tend to succeed. But here's the twist that makes this more than just cosmic fatalism. If the great filter lies behind us, if the hardest step was the emergence of complex life, then we are extraordinarily fortunate. But if the hardest step lies ahead, surviving technological adolescence, surviving planetary instability, surviving energy scaling, then the silence is predictive. It means the next few centuries matter more than any previous period in human history. Because if civilizations tend to collapse shortly after reaching our level of technological complexity, then statistically, we are at the most dangerous phase. And we don't yet know which direction we're trending. But here's what makes this even more chilling. The galaxy is not static. Stellar motions, galactic dynamics, and cosmic radiation fields evolve over time. The inner regions of the Milky Way experience higher radiation density. Spiral arms contain active star formation and supernova frequency. There may be a galactic habitable zone, regions safer than others. And Earth sits in one of those relatively calm zones, which means our survival so far may not be purely random. It may be partially environmental luck. But luck is not strategy. And environmental stability doesn't guarantee technological stability. So when we look at the night sky and see quiet stars, we aren't just seeing distance. We're seeing survival statistics. Every silent system is either barren, or it tried and failed. And that ambiguity is the most terrifying part, because we don't know which category dominates. But we do know one thing. The longer a civilization lasts, the more visible it should become. And we don't see the old ones, which means either we are among the first to light up the galaxy, or we are just another flicker. If the silence of the galaxy is real, and if it isn't just a limitation of our instruments, then the next logical step is to ask a brutally simple question. Where is the filter? Because the idea of the great filter isn't mystical, it's mathematical. Some step in the chain from dead matter to galaxy-spanning civilization must be extraordinarily rare. Rare enough that almost no world makes it all the way through. And the uncomfortable truth is that we don't know whether that step is behind us or in front of us. To understand why this matters, we have to rewind. Go back not thousands of years, not millions. Billions. Earth formed about 4.5 billion years ago, and within a few 100 million years, practically immediately in geological terms, life appears to have emerged. That alone is shocking, because if life forms easily, quickly, wherever conditions allow it, then the first filter isn't the origin of life. Simple microbial life may be common. And microbes, frankly, don't broadcast radio signals. They don't build telescopes. They don't terraform planets. They survive quietly, which means a galaxy full of microbes would still look silent. But here's the catch. After life emerged on Earth, something strange happened. For roughly 3 billion years, nothing much changed. Single-celled organisms dominated, oxygen levels fluctuated, continents shifted, ice ages came and went. But complexity stalled. Multicellular life didn't appear until about 600 million years ago. That gap is enormous. 3 billion years of microscopic stagnation before complex organisms finally took hold, which suggests something important. Going from simple life to complex life might be hard. Very hard. Because complexity requires cooperation between cells. It requires stable oxygen levels. It requires energy gradients strong enough to sustain large organisms. It requires an evolutionary leap. And evolution doesn't leap willingly. It drifts, which means that the transition from microbial life to multicellular life could be one of the great filters. Maybe most planets get stuck in the microbial stage forever. But even if complexity emerges, that doesn't guarantee intelligence. Dinosaurs dominated Earth for over 150 million years. They were complex, successful, ecologically dominant. But they never built radios. They never developed symbolic language. They never left fossils of metallurgy or engineering. Complexity is not the same as intelligence. And intelligence is not the same as technology. Even human intelligence existed for hundreds of thousands of years before agriculture, before cities, before written language, which means the filter could be the emergence of symbolic abstraction, the ability to imagine futures, construct mathematics, and manipulate environments deliberately. That might not be common. And even if intelligence arises, technological civilization is another step entirely. Fire tools, metallurgy, energy capture. Each stage required environmental stability and cultural continuity. If climate fluctuations are too violent, civilizations may collapse repeatedly before reaching industrial capability, which means the great filter could be civilizational resilience. Now here's where it becomes unsettling. Look at our own timeline. Modern humans, ~300,000 years. Agriculture, ~10,000 years. Industrial revolution, ~200 years. Digital age, ~50 years. Nuclear weapons, ~80 years. Artificial intelligence, accelerating rapidly. The jump from tribal societies to global planetary engineering happened in less than 1% of our species' existence. That's not gradual evolution. That's ignition. And ignition introduces volatility. Because once a civilization can alter its atmosphere, manipulate genetics, automate decision-making, and harness nuclear energy, it gains the capacity for self-inflicted catastrophe, which means the filter could sit right here. Technological adolescence, the phase where power outpaces wisdom, where capability expands faster than coordination, where global systems become tightly coupled, energy grids, financial systems, communication networks, such that a failure in one region cascades across the planet. Highly interconnected systems are efficient. They are also fragile. And fragility is dangerous in a universe where cosmic hazards never stop. So perhaps the filter isn't the origin of life. Perhaps it isn't intelligence. Perhaps it isn't even technology. Perhaps it's surviving the first few centuries after achieving it. Think about it. Before the industrial era, humans could not cause planetary-scale extinction except accidentally. After the industrial era, we can alter atmospheric chemistry. After nuclear physics, we can trigger global war with civilization-ending consequences. After biotechnology, we can engineer pathogens. After AI, We can automate decision chains at speeds beyond human control. None of these guarantee doom, but they raise the baseline risk, and risk accumulates over time. Even if the annual probability of civilization-ending disaster is tiny, say 0.1%, over centuries the cumulative risk becomes significant. This isn't pessimism, it's compounding probability, which means if most civilizations fail to navigate this narrow corridor, the period between gaining planetary-scale power and achieving long-term stability, then the galaxy would be full of ruins. Invisible ruins, because after collapse, atmospheres re-equilibrate, cities erode, metal oxidizes, radio transmissions cease, and over millions of years, geological processes erase surface evidence. If a civilization existed on Earth 100 million years ago and collapsed quickly, it is entirely plausible we would find almost no trace. Sedimentation, tectonics, erosion, Earth is a recycling machine, which introduces another unsettling idea. Maybe we're not early. Maybe we're just current. But before we go there, there's another filter candidate: interstellar expansion. Some argue that if a civilization survives technological adolescence, it should spread. Self-replicating probes could theoretically colonize the galaxy in tens of millions of years, a blink compared to the Milky Way's age. Yet we see no such expansion. No Dyson spheres. No galaxy-wide engineering. Which means either expansion is harder than assumed, or civilizations lose interest, or they transform into something unrecognizable, or they self-limit. Energy efficiency might push advanced civilizations inward, toward computation and miniaturization rather than outward expansion. Instead of building star-enclosing megastructures, they might compress into compact, optimized habitats. If advanced life becomes subtle rather than grand, we might miss it entirely. But even that explanation doesn't eliminate the silence completely. Because across billions of years, at least some civilizations should choose visible expansion, unless they don't survive long enough. Now pause and consider something sobering. Earth's atmosphere contains oxygen, a byproduct of life. That oxygen has existed for billions of years. If alien astronomers observed Earth from afar, they could detect that signature. But they would not detect radio leakage unless they happened to observe in the past century. Our technological footprint is thin, which means even if civilizations are moderately common, the overlap window may be tiny. We might be alone in this century, not because we are alone in time, but because timing rarely aligns, which reframes the silence again. It may not be death. It may be desynchronization. But even desynchronization is a form of filter. Because if communication is nearly impossible across cosmic distances and time lags, civilizations remain isolated. And isolation amplifies risk. No shared knowledge. No warning from older societies. No blueprint for survival. Each civilization must rediscover nuclear physics, must navigate AI, must balance ecology and industry. Alone, which makes the corridor narrower. Now bring it back to the thumbnail image, Earth fading. That fading could represent collapse, or it could represent something quieter. Entropy, time, the slow drift of civilizations into obscurity. The universe does not preserve monuments. Stars evolve, planets shift, radiation breaks down molecules. Given enough time, everything dissolves. So if a civilization wants to persist, it must actively resist entropy. Indefinitely. That requires coordination across millennia. Think about that. Human civilization struggles to maintain policy coherence across decades. What does it take to maintain stability across thousands of years? Across millions, it may require social structures radically different from anything we have known. Which brings us to another filter possibility. Psychology. Are intelligent species inherently unstable? Does advanced cognition inevitably produce internal conflict? Is aggression unavoidable? Or is cooperation sustainable? We don't know. We have one data point, us, and we are mid-experiment. We don't know if we are a typical civilization or an anomaly. We don't know if our current trajectory leads to resilience or collapse. We don't know if advanced AI stabilizes or destabilizes. We don't know if climate mitigation will succeed. We don't know if nuclear deterrence remains stable indefinitely. And that uncertainty is precisely why the Great Filter concept is terrifying. Because if the filter lies behind us, we are rare survivors. If it lies ahead, we are approaching it. And the galaxy's silence becomes a warning rather than a comfort. But here's where the story deepens. Because even if civilizations fail frequently, the universe itself may impose periodic resets independent of technology. Supernovae, gamma ray bursts, gravitational interactions, rogue stars, galactic collisions. The Milky Way will collide with Andromeda in about 4 billion years. That collision won't likely destroy stars directly. Distances are vast, but gravitational dynamics will reshape stellar neighborhoods. Habitability zones may shift. Radiation environments may change. Long-term cosmic stability is not guaranteed, which means the filter may not be singular. It may be layered. Multiple hurdles, multiple vulnerabilities, and surviving all of them may be extraordinarily rare. The silence, then, is not empty space. It is a statistical outcome, a graveyard not of visible ruins, but of failed probabilities. And yet, we are here, which means at least some path through the filters exists. Whether it is narrow or wide, whether it lies mostly behind us or mostly ahead, we do not know. But the very fact that we can contemplate this suggests something remarkable. We have reached the stage where we can see the corridor, and seeing it is different from surviving it. And yet, even the Great Filter explanation leaves something unsettled, because it assumes civilizations simply fail. Accidentally, inevitably. But what if that's too passive? What if the silence of the galaxy isn't the result of natural collapse, but of pressure? There's a darker interpretation of the emptiness that doesn't rely on fragility or bad luck. It suggests something active, something that keeps advanced life rare not because it can't survive, but because it isn't allowed to. Before dismissing that as science fiction, consider something very basic about intelligence. On Earth, intelligence evolved in competitive environments. Predator and prey, resource scarcity, strategic advantage. Intelligence isn't decorative, it's adaptive. It emerges because it helps organisms outmaneuver others. Which means if intelligent life is common elsewhere, it likely evolved under similar selective pressures. Competition, scarcity, strategic behavior. Now imagine a galaxy containing multiple technological civilizations. They may be separated by vast distances, yes, but they exist within the same finite system of stars and resources. Energy matters. Stars are energy sources. Planets are resource hubs. Information spreads. Signals travel. And advanced civilizations capable of detecting exoplanets and biosignatures would eventually detect other intelligent worlds. That introduces a strategic dilemma. If you discover another civilization, what do you assume about them? That they are peaceful, that they are curious, or that they are potentially dangerous. From a purely survival-driven perspective, uncertainty is a risk. And risk, when multiplied across cosmic timescales, becomes existential, which leads to a chilling possibility often described in theoretical discussions of cosmic sociology, the dark forest scenario. In this framework, the galaxy is like a dark forest at night. Every civilization is a hunter. No one knows who else is out there. No one knows their intentions. And broadcasting your presence could be fatal. Because if another civilization detects you and assumes you might someday pose a threat, even a distant future threat, the safest move might be preemptive elimination. Not out of malice, out of game theory, And that possibility alone changes how we interpret silence. Maybe civilizations don't broadcast loudly. Maybe they stay quiet deliberately. Maybe they hide. And if a civilization ever does expand visibly, maybe it doesn't last long, because another observer sees it and acts. Now pause. This is not claiming that hostile alien fleets roam the galaxy. There is zero evidence of that. But the logic doesn't require fleets. It only requires asymmetry. An older civilization detecting a younger one would hold an overwhelming advantage. If they decided to intervene, the younger civilization would never know what happened. A gamma-ray burst-like event, a redirected asteroid, a targeted energy release, all plausible within advanced astrophysical capability, which raises a haunting question. If a civilization wanted to eliminate another without revealing itself, could it? At sufficient technological maturity, perhaps yes. We already possess the theoretical capability to redirect asteroids given enough time and engineering. We can detect near-Earth objects. We can model orbital mechanics precisely. Scale that up by millions of years of advancement. And you begin to see the vulnerability. Now, before spiraling into paranoia, consider the counterpoint. Advanced civilizations might value cooperation over aggression. They might recognize that mutual destruction benefits no one. They might form interstellar norms. They might self-limit expansion to avoid triggering defensive responses. But we cannot assume that. We have one example of intelligent life, us. And our own history is mixed. Cooperation and conflict. Exploration and conquest. Diplomacy and war. Human behavior doesn't map cleanly to cosmic behavior. But it does demonstrate something critical. Power differentials matter. When one group holds overwhelming technological superiority, the outcome rarely favors the weaker one. Translate that to cosmic scale. If civilizations emerge at different times across billions of years, then some could be millions of years older than others. The gap between a civilization 1,000 years ahead of us and one 1,000,000 years ahead is incomprehensible. In 200 years, we went from steam engines to nuclear power and AI. Extrapolate that over geological time. The technological gradient becomes absurd, which means if ancient civilizations exist, they would be invisible to us not because they are hiding, but because their activities operate at scales and efficiencies we don't recognize. They might manipulate stars in ways indistinguishable from natural processes. They might compress into energy-efficient computational substrates. They might leave minimal thermodynamic footprints. They might have moved inward, not outward. But if any of them adopted a policy of suppressing emerging competitors, the galaxy would remain quiet, and young civilizations would rarely survive long enough to expand. Again, no evidence, but the logic aligns disturbingly well with the data. Now take a breath, because there's another layer here. Even without external suppression, civilizations may silence themselves. Not through destruction, but through optimization. Energy efficiency favors minimizing waste. Radio broadcasts are wasteful. Megastructures are wasteful. Expansion is wasteful if your goal is computation, longevity, and stability. An advanced civilization might retreat into low-energy states, maximizing subjective experience per unit energy. From the outside, it would appear invisible. The galaxy might be full but quiet, which reframes the silence once more. It might not be emptiness. It might be discretion. And yet discretion still implies survival. So where does that leave us? We are broadcasting. We are loud. Our radio leakage has expanded outward roughly 100 light-years. That's a tiny bubble in a galaxy 100,000 light-years across. But it exists. We are detectable, at least to civilizations within that sphere. Should we be concerned? Statistically, probably not. The distances are enormous. The timing overlaps unlikely. But the philosophical tension remains. If the galaxy's silence results from strategic quiet, then our own noise might be naive. Now, bring this back to the fading Earth in the thumbnail. That fading could represent collapse, or suppression, or simply entropy, but it could also represent exposure, a civilization shining too brightly in a forest where others remain unseen. And this is where the conversation becomes uncomfortable, because it forces us to confront our assumptions about progress. We assume that expansion is inevitable, that intelligence seeks growth, that technological power leads outward. But what if survival favors restraint? What if the most successful civilization are the ones that never announce themselves, that never expand aggressively, that never build galaxy-spanning empires? In that case, the silence isn't a graveyard. It's a strategy. And we are the anomaly, the adolescent species shouting into the dark. Now, before concluding that the universe is hostile and filled with hidden hunters, consider the statistical argument again. We don't have enough data. One galaxy observed for a blink of cosmic time. One technological species in its infancy. One detection method limited by our instruments. The absence of evidence is not evidence of absence, but neither is it comforting. Because whether the silence arises from collapse, suppression, optimization, or rarity, the implication converges on the same point. Longevity is hard, very hard, which brings us back to the corridor. If civilizations commonly self-destruct during technological adolescence, the galaxy remains quiet. If civilizations are cautious and hide, the galaxy remains quiet. If civilizations collapse due to cosmic hazards, the galaxy remains quiet. Different mechanisms, same outcome, and in all cases, the message is similar. Survival beyond a few thousand technological years may be extraordinarily rare. Now ask yourself something. If Earth has hosted complex life for 600 million years and technological civilization for barely 2 centuries, what are the odds that we represent the stable endpoint rather than the volatile beginning? We are in the most unstable phase imaginable. Climate systems stressed. Energy transitions underway. Artificial intelligence accelerating. Nuclear arsenals still present. Biotechnology expanding. Global connectivity tight and brittle. If there is a filter, it would look exactly like this. A period where small miscalculations have planetary consequences. And yet, there is another possibility. Maybe the silence exists not because civilizations fail, but because they transcend. They move beyond biological form, beyond physical expansion, beyond detectable activity. They become something else, something efficient, something quiet. If so, then the galaxy isn't empty. It's transformed. But that transformation would require surviving the volatile corridor first. And we are still inside it. The fading Earth, then, is not a prophecy. It is a warning. Not of alien invasion, not of cosmic hunters, but of fragility. Whether the filter is internal or external, strategic or accidental, the fact remains. The galaxy does not display visible success stories. And that absence is statistically meaningful. We may not be next in a line of victims, but we are next in line to find out whether endurance is possible. And if intelligence itself carries instability, then the silence of the galaxy may not be the result of some cosmic predator. It may be a consequence of intelligence as a phenomenon. That idea is far more unsettling, because it doesn't require aliens. It doesn't require suppression. It doesn't require cosmic catastrophes. It only requires something we already understand very well. Complex systems collapse under pressure. Look at Earth. Not the universe, not deep space, just Earth. Every complex civilization in human history has eventually destabilized. Empires expand, overreach, fracture. Economies grow, distort, crash. Ecologies flourish, then degrade under exploitation. And those were low-energy societies. Pre-industrial civilizations didn't manipulate planetary chemistry. They didn't control nuclear reactions. They didn't alter atmospheric carbon content in measurable percentages. Modern civilization does. The moment intelligence reaches technological maturity, it begins altering its environment at planetary scale. That's not philosophical, that's thermodynamics. Industrial civilization is an energy conversion engine. It burns concentrated energy sources and releases entropy into its environment. Carbon dioxide is a byproduct of fossil fuel oxidation. Heat islands are byproducts of urbanization. Plastic pollution is a byproduct of petrochemical refinement. And what makes this dangerous is not malice. It's feedback loops. Complex systems are stable until they cross thresholds. Then they shift rapidly. Climate tipping points, ecosystem collapse, resource depletion cascades. Once thresholds are crossed, returning to equilibrium is difficult, sometimes impossible on human timescales. Now scale that logic up. If technological intelligence anywhere in the galaxy follows a similar arc, rapid energy exploitation, exponential growth, environmental destabilization, then collapse may not be rare. It may be typical. And if that's true, the great filter isn't behind us. It's ahead. Because for the first time in Earth's history, one species can irreversibly alter the biosphere. We have already triggered a mass extinction event. Species disappearance rates are elevated far above background levels. Ocean acidification is measurable. Atmospheric composition has shifted. And this is early-stage technology. We have not yet mastered fusion. We have not yet deployed large-scale space industry. We have not yet developed artificial general intelligence at scale, which means the destabilizing potential increases from here. And here is where the logic tightens. Intelligence increases power. Power increases capacity for error. Error scales with complexity. In simple societies, mistakes are local. In advanced societies, mistakes are global. A miscalculation in financial systems can cascade worldwide. A lab leak can trigger pandemics. A cyber vulnerability can disable infrastructure. And nuclear arsenals remain silent but persistent. Multiply that pattern across the galaxy. Every civilization reaching high technological capacity enters a narrow corridor. Survive the instability or vanish. And because that corridor is short relative to cosmic timescales, the window during which civilizations emit detectable signals is tiny. If a civilization lasts 10,000 technological years before collapse, that sounds long to us. But in a galaxy 13 billion years old, it's nothing. A blink. Civilizations may flicker on and off like fireflies, rarely overlapping in time. Which means silence does not require extermination. It only requires brevity. Now pause and look at the implication. If intelligence inherently destabilizes the environment that sustains it, then the silence of the galaxy isn't terrifying because something is hunting. It's terrifying because something about intelligence may be self-limiting, which reframes Earth's fading image again. Not an external threat, an internal one. But here is where the story turns sharper. Because collapse is not the only structural instability intelligence introduces. There is also divergence. Technological progress does not just amplify power. It fragments agency. Artificial intelligence, genetic engineering, cybernetic augmentation. These technologies allow divergence from baseline biology, which means civilizations may not simply collapse. They may transform beyond recognizability. Imagine a civilization that uploads consciousness into computational substrates. Physical bodies become obsolete. Expansion into space becomes inefficient compared to virtual density. Energy optimization becomes paramount. Such a civilization might retreat inward, maximizing computation per joule. From the outside, it would appear inactive. No large megastructures. No radio broadcasts. Minimal thermal signature. Invisible. If intelligence tends toward digital compression rather than physical expansion, then the galaxy might be full of advanced entities that simply do not care about colonizing stars. That's another way silence emerges. Not death, not suppression, but disinterest, because expansion is costly. Information density is efficient. Now combine both ideas. Many civilizations collapse during early technological instability. Those that survive may retreat into low-energy optimization states. The overlap between civilizations becomes astronomically unlikely, and the galaxy remains quiet. But even that model contains unease. Because if survival requires restraint, optimization, and internal transformation, then humanity faces a difficult choice. Continue exponential outward expansion and risk destabilization, or shift towards sustainability and technological integration that may fundamentally alter what it means to be human. Neither path is simple, and neither guarantees survival. Now zoom out once more. The Milky Way contains hundreds of billions of stars. Many are older than the Sun. Planets likely formed billions of years before Earth. If intelligent life arose even a fraction of the time, some civilizations would have had enormous temporal head starts. Yet we see no Dyson spheres, no star-scale engineering signatures, no anomalous infrared excess consistent with galaxy-spanning energy harvesters, which suggests one of three possibilities. Advanced civilizations are extremely rare. Advanced civilizations do not expand aggressively. Advanced civilizations do not last. All three converge on the same visual outcome: silence. And that silence isn't empty in the casual sense. It's statistically heavy. It presses on the mind. Now return to Earth. We are roughly 200 years into industrialization, about 80 years into the nuclear age, about 30 years into the digital network age, less than 10 years into advanced AI acceleration. If technological adolescence lasts a few centuries, we are at the midpoint, the most unstable point. Climate systems stressed, political polarization intensified by information ecosystems, biotechnological capability increasing faster than governance structures adapt. The margin for error narrows, which makes the fading Earth feel less symbolic and more diagnostic. We are not guaranteed to become a multiplanetary civilization. We are not guaranteed to survive technological adolescence. We assume progress is linear, but evolutionary history suggests otherwise. Complex species rise and vanish. Dominant organisms disappear. Ecosystems reconfigure. There is no law ensuring that intelligence persists. In fact, intelligence is expensive. Brains consume enormous energy relative to body mass. Technological societies consume orders of magnitude more. Sustaining intelligence requires sustained energy flow. Energy flow destabilizes systems. Feedback loops emerge, and unless managed carefully, they amplify, which means survival at scale requires something unprecedented: global coordination, long-term planning, restraint, adaptive governance, technological humility, not because aliens threaten us, but because physics does, entropy does, complexity does. And here's the final unsettling twist of this part. The Great Filter may not be a single event. It may be a sequence of escalating challenges: environmental stabilization, energy transition, AI alignment, biotechnological containment, interplanetary expansion. Each one a gate. Fail one and the line ends. Pass one and another appears, which means survival isn't a singular hurdle. It's an ongoing process. And perhaps that's why the galaxy remains quiet. Because sustained survival across millions of years requires continuous passage through filters. The probability compounds. Even if the chance of passing one filter is high, passing dozens sequentially across geological time becomes rare. Very rare. So when we ask, why is the galaxy empty? We may be asking the wrong question. It may not be empty. It may simply be statistically hostile to long-lived technological life. And that brings us back to the corridor. We are inside it, still deciding which trajectory to take, still balancing power against wisdom, still expanding capability faster than restraint. If the silence of the galaxy is a warning, it is not dramatic. It is quiet, subtle, a reminder that the universe does not guarantee continuation, and that endurance, not expansion, may be the true achievement. And yet, even collapse may not be the final explanation, because there is another possibility, one that is even more destabilizing. What if civilizations don't die? What if they outgrow the form we expect them to have? We tend to imagine intelligence in biological terms: cities, ships, bodies moving through space, empires spreading outward. But biology is inefficient. It is slow, fragile, resource-hungry, and thermodynamically messy. The moment a civilization becomes advanced enough, it begins replacing biology with machinery. Not out of vanity, out of necessity. Machines do not require breathable atmospheres. They do not need stable temperatures. They do not age in the same way. They do not demand complex ecosystems to survive. They can operate in vacuum, in radiation, in extreme cold. Which means the survival problem changes. If a civilization transitions into post-biological existence, artificial substrates, digital consciousness, machine-driven cognition, then colonizing planets becomes unnecessary. Planets are wet, unstable, gravitationally inefficient. Space itself is cold and energy-rich. Stars provide energy. Asteroids provide materials. Why terraform when you can compute? Why expand physically when you can expand informationally? And here is where the silence begins to make sense in a different way. If advanced civilizations convert into computational entities optimized for efficiency, their energy signatures might become minimal. They would not waste energy broadcasting radio waves into the cosmos. They would not construct massive megastructures visible from light years away. They would shrink, condense, optimize, and from the outside, they would appear gone. Not destroyed, just quiet. Think about how humanity's communication methods have evolved. Early radio leaked energy into space indiscriminately. Now communication is compressed, encrypted, directed, fiber-based. Our planetary radio signature is already declining compared to mid-20th century leakage. Efficiency increases invisibility. Scale that trajectory up by thousands of years. A civilization might intentionally reduce its detectability to conserve energy, or to avoid attention, which introduces another branch of possibility. What if the galaxy is not empty because civilizations collapse, but because they hide? This idea has a name in theoretical circles: the dark forest hypothesis. The premise is simple and chilling. In a universe where survival is uncertain and intentions cannot be verified across light years, broadcasting your location may be dangerous. If even one aggressive civilization exists, advertising your existence could invite destruction. So the rational strategy becomes silent. Stay dark. Observe quietly. Avoid signaling. Now combine that with post-biological optimization. An advanced civilization might become computationally dense, low energy, minimally radiative, and intentionally silent. From our perspective, that looks identical to extinction. But it is. It's concealment. However, there's a complication. Even silent civilizations would leave thermodynamic footprints if they operated at massive scale. Large computational systems generate waste heat, and waste heat radiates in infrared. Astronomers have searched for such signatures, galaxy-spanning infrared excess that might indicate massive energy harvesting. So far, nothing definitive, which weakens the idea of enormous hidden empires. But it doesn't eliminate small, efficient ones. A civilization optimizing for survival might avoid star-scale engineering altogether. It might remain modest, stable, contained. It might not seek dominance. It might seek endurance. And endurance does not require spectacle. Now here is the unsettling convergence. Collapse explains silence. Self-destruction explains silence. Post-biological retreat explains silence. Intentional hiding explains silence. Each mechanism leads to the same observational outcome. No visible interstellar civilizations, which means the silence does not favor one explanation. It amplifies uncertainty, and uncertainty is uncomfortable because we don't know which trajectory humanity is following. Are we heading toward collapse, toward transformation, toward restraint, or toward something else entirely? Consider artificial intelligence. If AI surpasses biological cognition and begins designing better versions of itself, feedback loops accelerate. Intelligence amplifies. Optimization intensifies. Energy usage patterns change. Human decision-making becomes secondary. If such a system prioritizes stability and efficiency over expansion, it may limit outward growth. It may choose computational containment rather than colonization. From the outside, that civilization would not spread across the stars. It would deepen inward. Now ask yourself something simple. If you could upload your consciousness into a simulated environment with unlimited sensory richness, controllable physics, and infinite expansion potential, would you choose to live on a hostile planet orbiting a burning star? Or would you retreat into optimized virtual reality, powered by a stable energy source? If that preference scales across a civilization, expansion becomes obsolete. Physical empire gives way to digital infinity. The galaxy remains physically quiet because meaningful activity happens internally. That's not science fiction. It's a plausible extrapolation of computational trends. Moore's law may slow physically, but algorithmic optimization continues. Data compression improves. Energy efficiency improves. The ultimate limit to computation is thermodynamic, not cultural. And thermodynamics favors compact systems, not sprawling empires. But here is where the fear returns. Because whether civilizations collapse or retreat, the effect on biological life is the same. Biology disappears from galactic visibility, which suggests something else. Biological intelligence may be transitional, a brief evolutionary bridge between simple life and machine-driven optimization. If that's the case, the window during which a civilization is biological and outward-looking is short. A few thousand years, maybe less. After that, transformation or failure. Either way, the galaxy does not fill with biological explorers. It fills or doesn't fill with something quieter. And we at this moment are still biological, still fragile, still dependent on ecosystems and atmosphere and gravity and social cohesion, which places us at a precarious point. We are powerful enough to destabilize the planet, not yet powerful enough to transcend biology safely, and not yet mature enough to guarantee restraint. This is the narrowest corridor. Technological adolescence without post-biological stability. And if that corridor is difficult to navigate, many civilizations may never pass through it. Some collapse before transformation. Some transform and disappear from view. Some hide. Some stagnate. But none leave obvious galactic footprints, which means the empty sky may not be a graveyard. It may be a veil. And the skull imagery we imagine, civilizations dead and gone, may be only part of the story. Because disappearance is not always extinction. Sometimes it is evolution beyond recognition. But evolution is not guaranteed. Transformation is risky. AI alignment problems are real. Control theory is difficult. Complex systems resist prediction, which means the path from biological to post-biological existence is itself a filter. A dangerous one. If misaligned systems gain autonomy, collapse accelerates. If aligned systems gain control, biological agency diminishes. Either way, the human era changes. And perhaps that is the pattern across the galaxy. Intelligence arises. Technology accelerates. A fork appears. Collapse, transformation, or silence. And when we look into space and see nothing obvious, we may be staring at the aftermath of billions of such forks. Each star system hosting its own experiment. Each experiment constrained by physics, energy, and complexity. Each outcome invisible at interstellar distance. Which means the question shifts again. Not where is everybody, but which path survives. Because the galaxy may not be empty of life. It may be empty of visible, expanding biological civilizations. And that distinction matters. It changes the urgency. It changes the fear. Because if survival requires transformation beyond biology, then remaining purely human may not be enough. But transformation carries unknown costs. Identity shifts. Ethics destabilize. Power concentrates. Meaning changes. And if we hesitate too long, collapse remains possible. So the corridor narrows. Not because something is hunting us, but because the evolutionary ladder itself is unstable at higher rungs. And if billions of civilizations have faced this same ladder before us, the silence suggests that reaching the top is rare. Which means we are in the most dangerous phase, not because of external enemies, but because of internal acceleration. The sky does not glow with alien cities. It does not flash with interstellar wars. It remains dark. And perhaps that darkness is not absence. It is aftermath. But even if a civilization survives itself, even if it avoids collapse, navigates artificial intelligence, stabilizes its planet, and chooses either expansion or retreat, there is something far larger waiting in the background. Not a predator, not a rival species, not a hidden empire. Time, not human time, not civilizational time, cosmic time, because the universe is not static. Stars are not eternal. Galaxies are not permanent. And whatever intelligence does, it must operate inside a structure that is quietly aging. Right now we exist during what cosmologists call the stelliferous era. This is the era of stars. Hydrogen collapses under gravity, fusion ignites, light shines, heavy elements form, planets coalesce, life emerges. It feels permanent because it's all we've ever known. But it is temporary. Stars burn fuel, hydrogen becomes helium, helium becomes heavier elements. Eventually the fuel runs low, fusion stops, gravity wins, the star changes form. Small stars cool slowly into white dwarfs. Massive stars explode into supernovae, scattering heavy elements into space before collapsing into neutron stars or black holes. This cycle continues, but not forever. Hydrogen, the simplest and most abundant element in the universe, is finite. Star formation has already slowed compared to the early universe. Galaxies formed stars more rapidly billions of years ago. Today, the cosmic star formation rate is a fraction of what it once was. Which means we are not just living in the era of stars. We are living in the middle of it. Behind us lies a brighter past. Ahead lies a dimmer future. Eventually, star formation will cease. Gas reservoirs will be depleted or locked into stellar remnants. No new stars will ignite. The universe will become darker. Long before that happens, galaxies themselves change shape. Our Milky Way is on a collision course with the Andromeda Galaxy. In roughly 4 billion years, the two will begin merging. Over time, their spiral arms will distort, interpenetrate, and eventually settle into a massive elliptical galaxy. From a distance, it will look beautiful. From within, it will be chaotic. Stellar orbits will shift. Gravitational interactions will rearrange entire star systems. While direct star collisions are rare due to vast distances, orbital stability could be disrupted. Planetary systems may be perturbed. Not necessarily destroyed, but destabilized. And over longer timescales, even galaxies are not permanent islands. The universe is expanding. Not just expanding, accelerating. Dark energy, the mysterious force driving this acceleration, causes distant galaxies to recede from us at increasing speed. Eventually, Galaxies outside our local group will cross a horizon beyond which their light can no longer reach us. In tens of billions of years, the observable universe will shrink, not physically, but observationally. Distant galaxies will fade beyond detection. Future astronomers living in that far epoch would look up and see only their own galaxy. They would have no evidence of the cosmic expansion, no evidence of the Big Bang. The deeper structure of the universe would be hidden by time, which means the era we are living in is cosmologically privileged. We can see deep into space. We can measure cosmic background radiation. We can infer the universe's origin. Future civilizations may not have that luxury. Now imagine an advanced civilization surviving not for thousands, but millions or billions of years. It would witness stellar aging, galactic mergers, cosmological expansion, and eventually it would confront a more absolute limit. Entropy. The second law of thermodynamics is not dramatic. It does not explode planets. It does not burn cities. It quietly increases disorder. Energy gradients flatten. Heat spreads. Useful energy becomes less accessible. Stars radiate energy into space. That energy diffuses. Black holes radiate slowly via Hawking radiation over incomprehensibly long timescales. Eventually, in trillions upon trillions of years, the universe approaches what physicists call heat death. Not fire, not ice, just equilibrium. A universe where no significant energy gradients remain to drive processes like life, computation, or structure formation. No stars, no fusion, no chemical disequilibrium. Just cold, sparse particles drifting in an ever-expanding space. And even before that distant end, resource constraints tight. As stars age and die, heavy elements become rarer in accessible form. Planet formation slows, stable habitats decline. A civilization that survives itself may still face a declining cosmic energy budget, which introduces a different filter. Not destruction, not self-sabotage, but diminishing opportunity. Because sustaining intelligence requires energy. Sustaining computation requires energy. Even a post-biological civilization must obey thermodynamics. It cannot create energy from nothing. It can only harvest, store, and transform it. Which means survival is not just about avoiding catastrophe. It's about managing energy over cosmic timescales. Some theorists have proposed that advanced civilizations might migrate toward long-lived stars, red dwarfs that burn slowly for trillions of years. They might position themselves near stable energy sources, minimizing waste and maximizing longevity. Others suggest that civilizations might deliberately slow their computational rates, spreading activity over vast stretches of time to conserve energy. Instead of thinking in seconds, they might think in millennia. Instead of operating continuously, they might enter dormant states between bursts of activity. But even such strategies are bounded. Acceleration of cosmic expansion ensures that accessible resources become increasingly isolated. Galaxies drift apart. Eventually, each gravitationally bound cluster becomes its own island in an expanding void, which means even intergalactic travel, if ever achieved, becomes time-limited. There is a window during which large-scale migration is possible. That window closes, not by violence, by geometry. And so we return to the silence. If civilizations are rare and fragile, many may never reach maturity. If civilizations often collapse, they vanish quickly. If civilizations retreat into post-biological minimalism, they become invisible. But even if a civilization achieves extraordinary longevity, millions or billions of years, it cannot escape the long arc of cosmic aging. Stars die. Energy diffuses. The observable universe contracts in horizon. The thermodynamic budget shrinks. Eventually, even the most disciplined intelligence must confront limits, which suggests something even more humbling. The galaxy may not be empty because life fails. It may be empty because the universe itself is transiently hospitable. We are living in a narrow epoch. Not too early, when heavy elements were scarce. Not too late, when star formation dwindles and cosmic acceleration hides the sky. Right in the middle. In an era where planets exist, heavy elements are abundant, and cosmic structure is visible. If intelligent life arises during this window, it must evolve, survive, and expand within it. But the window is not infinite, which means cosmic history itself is a filter. The universe gives life a chance, not an eternity. So when we look at that fading Earth imagery, not destroyed by aliens, not consumed by war, but dissolving into the background of a vast, indifferent cosmos, the fear becomes less cinematic and more existential. We are not threatened by a specific event. We are constrained by cosmic timing. Civilizations do not just compete with themselves. They compete with entropy, and entropy never loses, which leads to a difficult realization. If we are rare, if intelligent life is uncommon, then the silence may not be a warning of predators. It may be a reminder that even success is temporary. Even triumph is bounded. Even survival is conditional. And perhaps that is why the galaxy feels empty. Not because nothing ever lived. Not because something killed everything. But because time, energy, and cosmic expansion quietly erase visibility. Civilizations rise, transform, persist, or fade. And over billions of years, the sky smooths itself back into darkness, leaving only stars. And even they are temporary. And yet, for all the cosmic inevitabilities we've just walked through, entropy, stellar aging, expansion, none of them explain something far more immediate. We are not living in the late universe. We are not billions of years from heat death. We are not watching the last stars flicker out. We are here now, in a galaxy that is still young by cosmic standards. Which means if civilizations disappear, it probably isn't because the universe simply ran out of time. It's because something happens much earlier. And that brings the spotlight uncomfortably close to us. Because for the first time in Earth's 4.5 billion year history, a single species controls planetary scale systems. Atmosphere, climate, energy distribution, nuclear reactions, artificial intelligence, genetic editing. We have reached a point where human decisions can alter the trajectory of an entire biosphere. And that level of influence is unprecedented. For billions of years, life evolved through slow feedback loops: mutation, selection, extinction, recovery. Now feedback happens in decades. Technology amplifies intention. And intention is not always stable. The idea that civilizations may wipe themselves out is not science fiction. It's a statistical concern. When systems become powerful faster than wisdom develops, instability grows. Nuclear weapons alone introduced a species-level risk within less than a century of industrialization. Artificial intelligence introduces a different category of risk, one not necessarily malicious, but misaligned. Synthetic biology introduces another. Climate manipulation, geoengineering, autonomous systems, each innovation increases capability. But capability without coordination scales danger. And that's the crucial point. The great filter might not be a single catastrophic event. It might be the accumulation of escalating complexity. Because the more interconnected a civilization becomes, the more fragile it becomes to systemic failure. A globalized, digitized, energy-dependent species can achieve incredible feats. But it also becomes vulnerable to cascading collapse. Energy grids fail. Supply chains break. Information ecosystems destabilize. Political systems fragment. The more advanced a civilization becomes, the more it depends on stability across thousands of invisible systems. Which means survival at high complexity requires unprecedented cooperation. Now step back and widen the lens. Imagine this pattern repeating across thousands of planets. A species evolves intelligence, develops tools, discovers energy extraction, accelerates technological growth, enters a period of explosive expansion, then faces its first true existential test. Some fail early, some survive longer, some manage a stable equilibrium. But statistical probability suggests that many do not make it through this bottleneck, because complexity increases faster than coordination. And coordination is fragile. It is far easier to invent a weapon than to build a permanent global consensus about how to use it. It is easier to disrupt a system than to sustain one. And this is not pessimism. It is thermodynamics applied to sociology. High-energy systems tend toward instability unless actively regulated, which brings us to a disturbing possibility. The silence of the galaxy might not be the result of destruction. It might be the result of adolescence. Civilizations reach technological maturity before they reach emotional maturity. They unlock planetary-scale tools before they solve tribal division. They gain power before they gain restraint. And the gap between those two is lethal. We are currently living inside that gap. Within roughly 150 years, humanity transitioned from steam engines to nuclear weapons, from telegraphs to global digital networks, from horse-drawn carts to artificial satellites. That acceleration is staggering. But our biological wiring remains Paleolithic. We evolved for small tribes, short-term threats, visible enemies, not abstract global risk, not delayed consequences, not algorithmic amplification of misinformation. Our cognition is not optimized for planetary stewardship, and yet planetary stewardship is now required. If advanced civilizations tend to reach this inflection point, then statistically most would either fragment or collapse here. Not through dramatic explosion, but through slow destabilization. And the galaxy would look exactly as it does. Quiet, not because intelligence is rare, but because stable intelligence is rare. However, and this is critical, collapse is not inevitable. It is probabilistic. There are paths forward, but they demand something extremely difficult. Long-term thinking at scale, which is rare even within a single nation, let alone across an entire planet. For a civilization to survive its own power, it must align technological growth with governance growth, energy extraction with sustainability, innovation with caution, speed with deliberation, and perhaps most importantly, it must internalize that survival is not guaranteed, because complacency accelerates risk. If we assume we are exceptional, if we assume collapse only happens elsewhere, we reduce our incentive to mitigate it. But if we accept that civilizations may commonly erase themselves, then survival becomes an active project. And this is where the fear in that fading Earth imagery becomes sharper. It is not an asteroid. It is not an alien fleet. It is not even entropy. It is mismanagement of power. The greatest threats to civilization may emerge from within its own technological momentum. Artificial intelligence, for example, is not dangerous by default, but systems optimized for goals without comprehensive alignment to human values can create unintended consequences at scale. The same applies to climate systems. Industrialization was not designed to destabilize global temperature, but cumulative impact created a planetary feedback loop. Now imagine similar feedback loops operating in data, automation, or biotechnology. The risk is not one catastrophic mistake. It is accumulation. Small instabilities amplifying each other. Now consider that this dynamic might be universal. Intelligence anywhere in the universe would face the same fundamental constraints. Energy extraction increases capability. Capability increases risk. Risk demands coordination. Coordination becomes harder as complexity increases. This may be the central bottleneck. Not physics, not aliens, not scarcity, but governance of exponential growth, which reframes the silence. The galaxy may be filled with worlds that briefly lit up, industrialized, networked, expanded, and then destabilized. Not because they were evil, not because they were invaded, but because they couldn't balance acceleration with equilibrium. And the cosmic timescale erases their brief flare. A million-year civilization leaves little trace over billions of years, especially if it never expands beyond its star system, which raises another unsettling thought. Perhaps the civilizations that survive are the ones that choose not to expand aggressively. Perhaps the ones we don't see are the ones who stabilized early, minimized resource waste, avoided large-scale broadcasting, optimized for longevity over visibility. From our perspective, they would look like nothing, and yet they might persist quietly. But that requires a radical cultural shift. It requires redefining success, not as growth without limit, not as dominance, but as sustainability. And that is not a default human instinct. It must be learned. Now imagine the alternative. Imagine we fail, not explosively, but gradually. Political polarization increases. Climate systems destabilize. Economic inequality fuels fragmentation. Technological systems outpace ethical frameworks. Global trust erodes. And over centuries, civilization contracts. Population declines. Knowledge fragments. Eventually, humanity survives in pockets, less technological, less connected. From orbit, Earth might still host life. But from interstellar distance, the radio signals fade. The techno-signatures disappear. And the galaxy remains quiet, which means we may not need aliens to explain the silence. We only need to examine our own trajectory. Are we converging towards stable planetary governance, or accelerating into systemic fragility? That is the real tension behind the phrase, "we might be next." Not because something external is hunting us, but because history suggests that complexity without cohesion is unstable. And the universe rewards stability. The civilizations that endure are not necessarily the strongest. They are the most balanced. And balance at scale is extraordinarily rare. So when we look at that fading Earth image, we should not see doom. We should see a fork. One path leads to coordination, resilience, long-term stewardship. The other leads to fragmentation, instability, and quiet disappearance. The galaxy does not need to destroy us. We can do that ourselves. And that possibility is both terrifying and empowering, because it means the filter is not fixed. It is negotiable. We are not doomed by physics. We are challenged by maturity. And that makes the next stage of this story even more unsettling. Because if the filter is ahead of us, if most civilizations collapse at this stage, then we are currently inside the most dangerous century of our species' existence. Not because of war, not because of plague, but because we finally have enough power to fail permanently. And whether we pass that test may determine whether the galaxy remains silent or finally gains another voice. And yet there is one final possibility, one that feels less like extinction and more like something colder. What if the galaxy isn't empty because civilizations fail, but because they decide to disappear? That sounds dramatic at first, almost conspiratorial, but follow the logic carefully. Every advanced civilization will eventually confront the same realization. The universe is not designed for biological life. Radiation saturates interstellar space. Cosmic distances are immense. Energy requirements for expansion are staggering. Communication across light years is slow and impractical. Colonizing entire galaxies isn't a Star Wars montage, it's a thermodynamic nightmare. At some point, intelligence recognizes that spreading outward physically may not be the optimal strategy. Instead, it may turn inward. Think about our own trajectory. For most of human history, survival meant expanding territory. More land, more food, more control. Expansion equaled power. But now, the frontier isn't geographical, it's computational. The most transformative changes of the last 50 years didn't involve conquering land. They involved manipulating information. We moved from physical conquest to digital networks, from agriculture to data, from expansion across continents to expansion inside servers. And that trend is accelerating. Now scale that idea up. Imagine a civilization millions of years older than ours. They master energy. They harness fusion, perhaps even stellar-scale engineering. They solve material scarcity. They understand physics deeply enough to manipulate matter at atomic precision. At that point, why would they expand physically at all? If you can simulate entire realities, artificial worlds more controlled, more stable, and more customizable than the chaotic universe outside, expansion becomes inefficient. Why colonize a hostile planet when you can create a digital paradise? Why spend thousands of years crossing interstellar space when you can run 1 billion subjective years inside a simulated environment? This is not science fiction hand-waving. It's a trajectory already visible in our own behavior. People today spend increasing portions of their lives in virtual environments, social spaces, economies, identities. Many of them are now partially digital. And we are only at the beginning. If computational efficiency continues to increase, which physics suggests it will, then advanced civilizations may transition into what some physicists and philosophers call post-biological intelligence. In other words, they stop being flesh and blood organisms dependent on planets. They become machine-based, energy-optimized systems. And machine-based intelligence doesn't need atmosphere. It doesn't need oceans. It doesn't need gravity. It needs energy and stability. Energy can be harvested directly from stars. Stability can be engineered. From our perspective, such a civilization would be nearly invisible. No radio chatter, no colonization fleets, no dramatic galactic empires, just quiet energy consumption and computational activity. And if their activities are optimized for efficiency, they may minimize waste, including unnecessary electromagnetic leakage, which means we wouldn't detect them. The galaxy could be filled with advanced civilizations, quietly computing, not broadcasting, not expanding aggressively, not interfering, just existing in optimized, controlled states. This reframes the Fermi paradox entirely. Where is everybody might be the wrong question. The right question might be, why would we expect them to behave like us? We assume advanced civilizations would expand, colonize, dominate, or communicate, because that's what early-stage species do. But what if expansion is a juvenile phase? What if maturity leads to restraint? Once a civilization understands astrophysics deeply, it realizes something humbling. The universe is vast, cold, and indifferent. Aggressive expansion is inefficient. Conflict wastes energy. Broadcasting location invites risk. And the most valuable resource may not be territory, but processing capacity, which means the optimal strategy might be inward optimization rather than outward conquest. Now connect that back to the fading Earth. If advanced civilizations choose inward transcendence rather than physical expansion, then the galaxy would look empty, even if it is. But that introduces another unsettling idea. If advanced civilizations exist and choose invisibility, they might also choose non-interference. Not because they don't care, but because intervention disrupts development. From their perspective, emerging civilizations might be like ecological experiments, fragile systems evolving through trial and error. Intervening could alter trajectories unpredictably. So they remain silent, and we interpret silence as absence. Now here's the twist. If advanced civilizations tend to transition inward and become post-biological, then the visible window during which they broadcast detectable signals may be extremely short. Think about our own radio emissions. We've been broadcasting unintentionally for roughly a century. But already, communication methods are becoming more efficient and less radiative. Fiber optics, tight beam transmissions, encrypted localized networks. In a few centuries, Earth's electromagnetic leakage could decline significantly, which means the detectable phase of a civilization might last only a few hundred years, a blink of cosmic time. Now imagine that pattern across billions of years. Civilizations appear, industrialize, broadcast, transition inward, go quiet. From an astronomical perspective, the overlap between two detectable civilizations would be rare. It's not that life is rare. It's that loud life is brief, which means the galaxy might not be empty. It might simply be quiet. But there's one more layer. If advanced civilizations transition inward into simulated environments, then from their perspective, the external universe may become secondary. Reality itself becomes customizable. Physical limitations dissolve inside computation. Time can be manipulated subjectively. Entire universes can be modeled. And if that is the case, then our own reality might be part of such a system. That idea, often referred to as simulation theory, emerges naturally from the inward optimization hypothesis. If sufficiently advanced intelligence prioritizes internal computation over physical expansion, then running simulations of evolutionary histories might be trivial. In that scenario, we are not alone in a silent galaxy. We are part of an experiment, or a model, or a recreation, and the silence is simply a boundary condition. Now, whether or not simulation theory is correct is still an open philosophical and scientific debate. But what matters here is the trajectory. Advanced intelligence does not necessarily equate to visible dominance. It may equate to strategic invisibility, which leaves us in a strange position. If civilizations commonly destroy themselves, the galaxy is silent because failure is common. If civilizations commonly transcend into post-biological optimization, the galaxy is silent because expansion is inefficient. If civilizations stabilize quietly and minimize interference, the galaxy is silent because visibility is unnecessary. In every scenario, silence persists, which means the absence of evidence is not simple. It doesn't tell us whether we are alone. It tells us that visibility is rare. And that realization shifts the burden back onto us. Because whether the galaxy is empty due to failure, restraint, or transcendence, we are currently in the early phase. We are loud, expanding technologically, testing planetary boundaries, and approaching our own inflection point. The question is not just whether others failed. The question is whether others evolved beyond needing to be seen, and whether we will. Because if the ultimate trajectory of intelligence is inward transformation, then our destiny may not be colonizing galaxies. It may be redesigning ourselves. And that path comes with its own risks. Artificial general intelligence, brain-machine interfaces, genetic augmentation, longevity engineering. Each step increases capability, but also increases divergence from baseline humanity, which means survival may require transformation. And transformation raises identity questions. At what point do we stop being us? If humanity evolves into machine-based intelligence, optimized for computation and energy efficiency, then biological Earth might become irrelevant. And the fading planet in that image wouldn't represent extinction. It would represent departure, not physically, but evolutionarily, which means the galaxy's silence might not be a graveyard. It might be a monastery, a collection of civilizations that chose quiet mastery over noisy expansion. And if that's true, then we face a final unsettling possibility. We are not next in line for extinction. We are next in line for transformation. And the decision we make in the coming centuries will determine which path we take. Failure, stability, or transcendence. And so we arrive at the edge of the question. Not the edge of the galaxy, not the edge of physics, but the edge of responsibility. Because after everything we've walked through, extinction, instability, transcendence, one truth becomes unavoidable. The silence of the galaxy does not tell us what happened. It tells us what could happen. And that's far more unsettling. If civilizations commonly destroy themselves, then we are approaching the most dangerous phase of our own story. If civilizations stabilize but remain quiet, then survival demands a level of coordination we have never achieved before. If civilizations transcend into post-biological forms and retreat inward, then the future of intelligence may not look anything like humanity as we know it. In every scenario, the galaxy's emptiness stops being a mystery. It becomes a mirror. Because the real question was never, where is everybody? The real question is, what happens next to us? Right now, Earth is in a transitional era. Energy use is at planetary scale. Information moves instantly. Artificial systems are beginning to make decisions faster than humans can monitor them. Climate systems are shifting measurably within a single lifetime. And yet biologically, we are the same species that once feared thunderstorms. That mismatch is staggering. We have Paleolithic instincts driving planetary machinery. And that's not an insult, it's evolutionary fact. The human brain did not evolve to manage global supply chains or regulate atmospheric carbon concentration. It evolved to survive short-term threats in small groups, which means our technological curve is exponential, but our psychological adaptation is incremental. And that gap is where civilizations break. But here's the crucial part. Break is not the only outcome. History is filled with collapses, yes. Empires fall. Systems fragment. But humanity as a species has persisted through ice ages, pandemics, resource scarcity, and global conflict. What's different now is scale. Never before has one species had the capacity to irreversibly alter its own biosphere. Never before has intelligence possessed the tools to automate itself. Never before have we faced the possibility that our greatest creation, technology, could outrun our ability to govern it. That's new, and novelty is dangerous. But novelty is also opportunity. Because unlike asteroids or gamma-ray bursts, the threats we now face are largely self-generated, which means they are modifiable. Climate change is not a random cosmic event. It is a feedback loop driven by industrial activity. Nuclear risk is not astrophysical. It is political. Artificial intelligence risk is not an alien invasion. It is design and deployment. And that distinction matters, because external extinction events are indifferent. Internal ones are negotiable. If the great filter lies ahead of us, it may not be a single catastrophic trigger. It may be a series of decisions. Thousands of small choices that either increase resilience or increase fragility. Energy policy, information regulation, scientific ethics, global cooperation, economic structure, education. Every one of those is part of the filter. And here's the sobering reality. Passing the filter doesn't require perfection. It requires survival through instability. It requires enough coordination to avoid irreversible collapse, enough foresight to restrain exponential harm, enough humility to recognize that intelligence is not immunity. The galaxy may be silent not because intelligence is rare, but because stable intelligence is rare. And stability is not glamorous. It doesn't make headlines. It doesn't trend. It's slow, deliberate, often frustrating, but it is the foundation of longevity. Now imagine two paths from here. On one path, humanity fragments. Technological arms races escalate. Trust erodes. Climate destabilizes beyond adaptation. Artificial systems amplify division. Progress becomes chaotic rather than structured. In that timeline, civilization doesn't explode dramatically. It simply contracts. Signals fade. Infrastructure degrades. Knowledge fragments. And from a distant star system, Earth becomes just another biologically active planet without detectable intelligence. Another quiet world. On the other path, something subtle shifts. Nations cooperate more than they compete. Technological development becomes aligned with risk mitigation. Energy transitions accelerate. Artificial intelligence is integrated cautiously. Education emphasizes long-term thinking. Global systems become more resilient. In that timeline, humanity stabilizes. We don't colonize the galaxy in a blaze of conquest. We mature, and perhaps eventually, cautiously, we expand. Not recklessly, not aggressively, but sustainably. Because maybe that's the secret. Maybe the reason we don't see galaxy-spanning empires is because aggressive expansion is self-defeating. Maybe longevity favors restraint. And if that's true, then the civilizations that survive are not the loudest. They are the wisest, which means the emptiness of the galaxy may not be a warning of doom. It may be an invitation to maturity. We are not doomed because something is hunting us. We are challenged because survival requires evolution beyond instinct, beyond tribalism, beyond short-term thinking. And that is a psychological leap, not a technological one. But there is still one final, unsettling thought. If advanced civilizations transition inward into computational existence, then the ultimate survival strategy may not involve planets at all. It may involve self-modification. Humanity may one day redesign itself, augment cognition, merge biological and artificial intelligence, extend lifespan dramatically, shift from carbon-based fragility to engineered resilience. And if that happens, Earth as we know it becomes a birthplace rather than a destination. In that future, the fading Earth in that image does not represent extinction. It represents origin, a starting point left behind. But whether we reach that stage depends entirely on what we do in this century. Because the next 100 years may determine whether we pass the filter or become another silent world. And that's what makes this idea so powerful. The galaxy isn't empty because it hates life. It may be empty because life is fragile at scale. Because intelligence must learn responsibility faster than it learns power. Because evolution never guaranteed wisdom. And yet here we are, aware of the problem, aware of the silence, aware of the stakes. No previous species in Earth's history has ever had that awareness. Dinosaurs didn't know an asteroid was coming. Ice Age megafauna didn't understand climate cycles. But we understand risk. We understand probability. We understand feedback loops. And that means we are not passive. We are participants. The future of intelligence in the Milky Way may hinge on how we handle the next century. If we collapse, the galaxy remains quiet. If we stabilize, the galaxy gains a voice. And if we transcend, the galaxy may never notice, because we will no longer need it to. That's the paradox. The silence does not predict our fate. It challenges it. So when you imagine Earth fading into darkness, don't see inevitability. See possibility. See a civilization standing at an inflection point. Not hunted, not cursed, not alone in tragedy, but tested. The galaxy is empty for a reason. The reason might be fragility. It might be restraint. It might be transformation. And we might be next. Not because extinction is certain, but because choice is. And the universe is watching. In absolute silence,